Hello everyone, welcome to my YouTube channel called Sim. Today I am going to discuss with you Fluery's algorithm. It is a simple and effective method to find Eulerian circuits in a graph. This algorithm is a fundamental concept in graph theory and has practical applications in network routing, urban plan and more. Let's get started. Okay. Mainly we will see what is the Eulerian graphs. Before we dive into Fluery's algorithm, let's understand the Eulerian paths and Eulerian circuits. Eulerian path means a path that traverses every edges exactly once. Eulerian circuit and Eulerian path that starts and ends at the same vertex. Eulerian circuits means an Eulerian path that starts and ends at the same vertex. Hello everyone, welcome to my YouTube channel called Sim. Today I am going to discuss with you the Fluery's algorithm. It is a simple and effective method to find Eulerian circuits in a graph. This algorithm is a fundamental concept in graph theory and has practical applications in network routing, urban plan and any other more. Let's get started. Mainly we will see what is the Eulerian graphs. Before we dive into Fluery's algorithms, let's understand Eulerian paths and Eulerian circuits. Eulerian paths mean a path that traverses every edge exactly once, and Eulerian circuit means an Eulerian path that starts and ends at the same vertex. See this graph. We can see there is 4 edges and 4 vertices. A, B, C, D is a vertices and AB, BD, DC, CA and BC are edges. We can go in these edges A, B and B to C, C to A and C to D and B to D, like this. The Fluery's algorithm means we finding the way to starting B and how to we can again come to B by going to all vertices. Okay, this is the Fluery's algorithm and Fluery's algorithm application to Eulerian circuits. Okay, then we will see this slide. In this slide, Eulerian's theorems. Okay, Eulerian conditions for Eulerian paths and circuits. What is Eulerian circuit and Eulerian path? Eulerian circuit exists if all vertices have an even degrees. Okay, Eulerian circuit exists if all vertices have an even degrees, and Eulerian path exists if exactly 2 vertices have odd degrees. If more than 2 vertices have an odd degree, then an Eulerian path is not possible. Okay, there are 2 key conditions to determine whether an Eulerian path or circuit exists in a graph. Okay, then we will see Fluery's algorithm's explanations. Okay, what is Fluery's algorithm? Fluery's algorithm is a step-by-step method to find Eulerian circuits and paths. It ensures that when traversing edges, we avoid breaking the connectivity of graph. Let's see how it works. Okay, we should mainly we should understand what is a bridge. Bridge is a main case of a Eulerian circuit and Fluery's algorithm, because we should understand what is a bridge and what is not a bridge. Okay, because we will see. Okay, a bridge is an edge that if removed would disconnect the graph. That means we can't remove the bridge, because if we remove the bridge, the graph is disconnect. Okay, that means graph can be disconnect to no parts. Okay, so bridge is an important concept in Fluery's algorithms. So the algorithm avoids bridges unless or no other choice is available. That this ensures the path remains valid. Okay, let's see this graph. In this graph there are 5 vertices, 1, 0, 2, 3 and 4. Also there is the edges 1, 2, 2, 0, 1, 2, 0, 0 to 3, 3 to 4. These are the edges and vertices. And see, this is 1, 0 edge. We can remove this edge, but removing this edge, this is not going to disconnect the graph. Also we can remove 1, 2 edge and also 2, 0 edge and also 3, 4 edge. But see this 0, 3 edge, 0, 3 edge. This 0, 3 edge we can't remove, because this is please see the second graph. If we remove this 0, 3 edge, this going to disconnect the graph into 2 parts. You can see there are 2 parts. And also I did a mistake. We can't also remove the 3, 4 edge, because if we remove this 3, 4 edge, this going to be also disconnect the graph into 2 parts, because the 4 vertex is going to be alone from the whole graph. So there are 2 parts also when we removing the 3, 4 edge. So both 0, 3 and 3, 4 edges are bridges in this graph. Okay, like this we can understand what is a bridge and what is a graph. Then we will see how to apply the Fluery's algorithm for a Eulerian circuit. Okay, Fluery's algorithm follows these 4 simple steps. We will see. First one is start at a vertex with an odd degree. We should start at a vertex with an odd degrees, or any vertex for a circuit. Any vertex for a circuit. Okay, we can also start at a vertex if there are one vertex exists. Okay, it also or degree. Okay, also then second one is choose an edge that is not a bridge. We should choose an edge which is not a bridge, and also unless it is the only option. Okay, then we should traverse the edge and remove it from the graph. The third one is we should traverse the edge and remove it from the graph. And the fourth one is repeat until all edges are used. We should repeat until all edges are used, ensuring the graph remains connected. Okay, then we will see an example for Fluery's algorithm application in Eulerian circuit. There is a Eulerian circuit, and we will see how to go on in this circuit. I am going to start at the vertex B. In the vertex B, we can go on 4 edges: B to F, B to A, B to D, B to C. There are 4 edges, and these 4 edges are not the bridges. So we can go on any edge. I am going to select B to F edge, and when we are select the edge, we should remove it. So B to F edge, I am going on B to F edge and going to remove B to F edge. Then in the vertex F, we can go on F to A, F to E, F to D. We can go on F to A, F to D, and F to E. There is also there are no any other bridges, because they are also edges. So we can go on any other edge. So I am going to select F to A edge. F to A edge. When we are going to F to A edge, we should remove F to A edge. Then in the vertex A, there are 3 edges: A to B, A to C, A to D. There is also no any other bridges, so we can go any other edge. I am going to select A to B. A to B. Then we are also in the start point. There are only 2 edges we can going, B to C, B to D. I am going to select B to D. We should also remove B to D edge, and now there are 3 edges we have to go. Please see, when we are in the D edge D, there are D to A, D to E, D to F edge, but because of we have removed B to F, F to A, F to A to B, and B to D edges, there are only have B to C, C to A to D, and D to E, E to F, F to D edges only. Because of this, when we are removing D to A edge, it has going to disconnect the graph into 2 parts, because the FDE vertex are in one part and going to be ABC in one part. Okay, so we can't remove D to A edge in now, so we can move on D to F or D to E. So I am going to select D to F edge, then D to F, and we can going only F to E edge. So we going on F to E, then E to D, then now we can go D to A edge. There is also remove these edges, so there are no any part, so we can go D to A edge, then A to C and C to B. This is the Fluery's algorithm application in the Eulerian circuit. So like this we can find the path from Fluery's algorithm. Then we will see what are the real world uses in the Fluery's algorithm. Let's apply Fluery's algorithms to real world. Okay, first one is network routing. Network routing ensures data transmission paths remain connected and also efficient data packet traversal. Then the urban planning. Urban planning uses Eulerian graphs to design roads and bridges efficiently, and also street cleaning and garbage collection follow Eulerian circuits to cover all roads efficiently, and also puzzles. puzzles Königsberg bridge problem. Also, then we will see the advantages and limitations in Fluery's algorithm. Like any algorithm, Fluery's algorithm has its pros and cons. The advantage is simple and also easy to understand and great for small graphs. But limitations are inefficient for large graphs. So we can't apply this. It is not can't. It is inefficient in large graphs and also requires checking bridges frequently. Then I think to summarize, Fluery's algorithm is a powerful method for finding Eulerian circuits by following simple steps and avoiding bridges. We can efficiently traverse every edge in a graph exactly once. Thank you for watching. I hope this explanation helped you understand Fluery's algorithm better. If you have any question, feel free to ask. See you next time. Please like, subscribe and share this video. Thank you.